Hello guys, this is Ravi Rajput. Welcome to my YouTube channel NextGen Neuron. So today we will do the coding exercise for transformers fine tuning. So if you have seen my previous video, what are transformers, right? So there I had mentioned what is the fine tuning process of transformers after explaining the entire mechanism of transformer. In the last you will see I had mentioned about fine tuning of transformer. So I'm rephrasing it again. What fine tuning is? So fine tuning is a process of retraining the pre-trained transformer on a specific data set. Okay, for example, your organization or you are working with a company which is an e-commerce company, right, or a pharmaceuticals company. So, and you are developing an AI model which is providing some out or some answers or doing its natural language processing task related to your organization or mostly related to pharmaceuticals data. So you are going to train it on your specific data set of pharma, right? So that's known as fine tuning to adapting the model based on your needs, right? So you know it's all about training. You just need to train the model on a specific data set and it will do its work for you. Okay, so here we have tried to explain what fine tuning is based on the coding. So yeah, so if you see, I have used the Google Colab workbook here, right? So Google Colab, it's provided by Google, so that's mainly used for deep learning programming, right? So they have provided, CPU as well as GPU as a runtime. So GPU is basically used in deep learning training because training is really very heavy process, as I had mentioned, right? So if you are going to do that using CPU, it's going to take a bunch of days or a big time, right? So it's always good to do that using GPU, right? So in GPU you can do in a matter of minutes. Okay, so first what I have done, I have installed the transformer libraries here, right? So if you see the transformer libraries from Hugging Face. Hugging Face is an open source website or open source community which is which is maintaining all types of transformer models with it, right? It's responsible for releasing various transformers or maintaining all the transformer model with it, right? So uh, once you have time, go through Hugging Face live, what Hugging Face is, right? So uh, yeah, coming back. So here what I have done for, oh sorry, I think I had deleted the incorrect cell. So first part is importing transformers, right? So pip install transformers. Okay, so this is going to download the required libraries for transformer from Hugging Face and importing for you. Now the second part is so yeah, so I'm going to show you the difference, guys, right? So this cell, what it says, uh, uh, what I have tried to do here is like I'm downloading the pre-trained a very general transformer from Hugging Face libraries, right? So that is bert-base-uncased. It's pretty generic and pre-trained transformer which was trained on normal general English, right? So I will try to do the sentiment analysis task, NLP task, right? So here, the sentiment analysis, like I'm just going to give a string and model will identify if it is a positive or no, what is positive sentiment or negative sentiment, right? So first I will show you how it is performing using a transformer which was trained on a very general English, which is or generic data, or it's a pre-trained transformer, right? So what I have done, I have imported all the required libraries. I'm trying to import the transformer from Hugging Face pipeline. So what I have done, this is tokenizer. Tokenizer is also specific to your transformer model. So this tokenizer is being downloaded from Hugging Face libraries and making sure the sentence or the passage or the sentence, the input string is being tokenized accordingly, which is suitable for your transformer. So I have downloaded a tokenizer. Next step is, yeah, so I'm downloading a bert-base-uncased pre-trained transformer from Hugging Face pipeline, and simply passing the inputs to it and see and then we will see what's the output going to be providing by this pre-trained transformer, right? So let me run it. Yeah, so it will take a little time while running. So yeah, so we'll see what will be the output of these sentiments, how those are analyzed. So now first it is downloading the transformer from Hugging Face library. It downloaded, and if you see, it has shown some label 0 with some very or almost medium level confidence. It showed 0. 0 means yeah, it's negative, right? So yeah, that is being classified as 0, and also showing as less human friendly. We don't know what 0 is, right? So and also the output should be wrong. So I have mentioned the movie was absolutely fantastic. I loved. So this is a positive comment. And the other one is this was a worst film. So it had classified both as same type of sentiments, both as negative, I think. Yeah. So this is something which needs fine tuning. If you see here, they have also mentioned some weights were not initialized. You should probably train this model on a downstream task to be able to use it for your prediction inference. So it's pretty basic, right? It's pretty general, or a pre-trained transformer on a general English, right? So now what I will do, I will fine tune this transformer for doing a sentiment analysis precisely, right? So that's our need. So what I have done first, I will organize the data, a big data set on which I will train my transformer so that it will become suitable for us. So again, I have used data sets library from Hugging Face. So data sets library is having a lot of pre-built data sets already available for us for use, right? So I have installed the data sets, and yeah, the next is again, I have may not be needed at this point, but this one should be needed. Auto tokenizer we had imported before as well, right? So may not be needed, but I have imported all the required libraries again for from transformer repo, and then yeah, this has been imported, right? The load dataset method as well as auto tokenizer and auto model for sequence classification. This is a class defined in Hugging Face library, which will give you the suitable model downloaded from their repository, which is yeah, suitable for your task for sequence classification, right? So now what I'm doing, I'm loading the IMDb dataset. So see guys, here I have used a pre-built dataset, IMDb dataset, for training the model on sentiment analysis task. So IMDb, that's used for that's a movie dataset, right? So this dataset is having lots of reviews and comments about the movies. IMDb, I think you all knows, right? So it rates the movies. It provides some ratings and reviews and all. So the same data set we will use to train our model. So we'll tell the model these type of reviews are positive and these type of reviews are negative. So those all are maintained in the IMDb dataset, right? So let's see how we train it. So what we have done, we have loaded the dataset, IMDb dataset, and it's loaded 100%. Now let's read some data here. Okay, so I think it's data is not defined. I'm not sure if I had. Okay, I think I did not run it. So let's do it one more time. Yeah, so it's loading the data. 100% data got loaded. Now let's run it. It printed some data. Yeah, so you can see this is how the data set is being printed here. Like it's having 25,000 rows in it, right? So yeah, trained, it has already split it into two parts, test data as well as untrained data. So uh, that is already being done by your library, the Hugging Face library, right? So it's automatically managing the data as per its need in trained data set as well as test data set. Okay, so you might also notice what I have done here. I have also loaded the model which I'm going to I'm going to fine tune. I have again loaded the bert-base-uncased model from Hugging Face library. So it has been downloaded in this model variable, right? So the model has been downloaded. Now this model we will train on our data set. So currently this model is a generic model, which is bert-base-uncased. Now now what we have got, we have downloaded the IMDb dataset, a big dataset for reviews and for our sentiment analysis task. And the second thing, we had downloaded the model as well, so which is a generic model for now, but we are going to fine tune it on our dataset. Now this is the function which is used to tokenize the data. If you see my previous video, what are transformers, right? So there I had mentioned for any NLP task, the data is first tokenized, okay, and then converted into feature vectors, so that will be processed. The data is not processed as it comes or it's straightforward, it needs to be tokenized first, right? So this function is going to tokenize it for you and making the data set adaptable for its use, right? So putting some additional tokens in it, and it is going to adapt it for its use, or suitable for its use, right? So uh, okay, execute this one. So tokenize function has been defined, so it's returning the tokenizer with examples text. It is pulling out text from it. Padding max length truncation is true, it will truncate when it will overflow. So that's an internal mechanism guys for tokenization. Okay, once the data has been tokenized, let's print some elements out of it. No, I don't think so. I had executed this one, tokenized data set. So now it is being tokenized, okay, based on the function I had defined above. So it's tokenizing entire 25,000 rows of it. Okay, let's give it a couple of minutes or seconds. Yeah, I would say few seconds. So now, yeah, it's being tokenized. Okay, so the data has been tokenized now. Now what I will do, let's print some rows out of it. So this data has been tokenized, see, and it has provided some. Yeah, so it might have provided, internally, if you print, you will see some attention mask and input IDs also have been assigned to these data after tokenized has been done. Here I did not print it, but yeah. So the thing is, after tokenization, the data is going to be manipulated as per what is needed by the model. Okay, it's tokenized, and now this is what I have done. I have imported the evaluate library as well, so this will help me to record some training and validation metrics, like how it is doing evaluation metrics. And here I had given the function. So these functions you will get, guys, you will get from Hugging Face libraries. If you go to Hugging Face website, they have provided the code snippet, which you can directly pick it from there and use it for your based on your need. It's for question answering as well, or for question answering, as well as for sentiment analysis. For everything they had provided, but you should know where and what you are going to use, right? So even you should know how it is working. So these all snippets are available there. So I am executing this evaluate function. So yeah, this compute metrics function, I had defined it here. So this function will help me to provide some learning metrics. Okay, now this is a transformer I had just imported a training arguments. Now we are going to start the training process here, right? So I had defined all the training parameters here. So as a training arguments, this is again, so guys, Hugging Face libraries are a wrapper around PyTorch. Those have been developed over PyTorch. Okay, so using the same specifications. So training arguments is a library where you can see I'm setting the training parameters here, output directory, where I'm going to export my model, right? So my model will be exported in this particular directory after has been trained. Okay, And the evaluation strategy, I'm using epoch. Epoch, I had already mentioned what epoch is. It's number of iterations, which how much the model is going to train. So how much time the model will iterate through the same data set. That's epoch. Here, since the data set is big, right, so model has enough data to learn, so that's why I had defined epoch as one. I'm assuming in a single epoch model will learn everything. We don't need the second iteration, because there is also uh, a concern, or you know if you are doing a lot of iterations on the same data set, so model will go overfit, right? So overfitting is bad. Overfitting means model has learned a lot of things, so it's not performing well on the testing data set, right? So just consider, like, after studying too much beyond the limit, a student has gone mad, kind of. Okay, so the similar thing is overfitting. So we have to avoid overfitting as well, and maybe I will explain some in a separate video what overfitting is. So, in order to avoid overfitting, we just need to make sure we are not training the model on the same data set excessively. So, we just need to, give the optimum value. So, here, since the data set is pretty big, of 25,000 rows, so I think so one epoch should be fine. Again, per device, and then batch size I had defined. So this is also uh, defined as per the optimum value for good performance of training. So if the batch size is smaller, so it will take much time. If the batch size is bigger, it will take lesser time in training. But you also need to make sure that the available memory is going to be supported, whatever the batch number you are selecting. Okay. uh, so you just need to select it based on the available memory and resources, right? So how much batch you should define. So I have defined 50. Going beyond 50, it will start breaking, breaking my resources, or breaking my GPU here, right? So so for me 50 is the optimum value, and the learning rate is, this is the learning rate on which the model is learning, right? So I will describe what this learning rate and other hyperparameters are in a separate video of I'm planning to create a separate video on training and validation. So but for now, just know that this is a learning rate on which the model will run based on this rate. Okay. And seed, as I had mentioned, seed 42, it's just for reproducibility, in like, to avoid getting the random training results. So we just need to set the seed at a specific number, so model will start from the same point, will train every time in a same manner, so it is expected to provide the same result after each training, right? So it will not provide you the randomness. So that's why we had done the seed. So these are the required parameters, so let me execute it. So the training arguments have been populated now, and now here it starts training, right? So there is a class trainer from Hugging Face library, where I am just putting all these training argument as well as model, which I am going to fine tune, and the tokenized data set what we had tokenized, right? So all the required inputs to it, and compute metrics to record the uh, figures or stats. I'm running the training. So see, the training now has been started. It is asking me some API keys. I think I can get it from here. So this vendb.ai is also, I think, that has been integrated with Hugging Face transformers. So you just need to provide the authorization key from it, and then it will go for further training. Let me see if I can arrange it. So yeah. Yeah, so this is my key. I am just going to put it here, putting enter. So yeah, the training is going on now. Yep. So it has the training has been started. First epoch started. It will take almost 7 minutes. So guys, you see here the training is done and yeah, completed. So if you see the stats which have been provided are looking as accuracy as 93%, validation loss is 0.17, and training loss is 0.24. So loss I had mentioned the correctness of the model, right? So or the mistakes. So accuracy is 93%. Seems good. Like so after going through the after going through that entire data set of 25,000 rows, so the model learned to classify the sentiments with 93% of accuracy here, right? So okay, now the next step is I had tried to put some configuration here. So if the label is 0, and model will show it as negative, or if it is 1, then model will show it as positive, right? So to show it as more human friendly. Okay, so and this is the path where I'm going to save the model. So after executing this, whatever I had trained here, so all those weights are going to be saved at this location, or my model is going to be saved at this location. Okay, I have executed it. So now my model should have been put there already. Yeah, so it's here. So if I'm expanding it, so it's showing as sentiment analysis next gen. So these are my model parameters. Okay, so or my model which have been saved. So now what we will do next step is I'm going to load this model instead of BERT or the generic, as I did before, right? In the starting I had loaded the BERT, a generic model, and perform the inference on it, but here I'm just going to download this model, or I'm just going to load this particular model from this location and whatever we have trained now so far, and we will use it and see how it is performing on the inputs whatever we pass. Okay, so this is the code. If you see again, instead of loading it from the Hugging Face pipeline, what I have done, I have loaded it from this particular path, next gen neuron, fine tuned sentiment analysis, blah blah. So this is the same location. Now after executing this line, it will load my model from this location. Okay, and these are few input strings, and we'll see how our model is identifying those strings or classifying these strings. Okay, so the first one, it's shown as positive with 99% confidence. Okay, so first one, my movie was absolutely fantastic, and definitely it's a positive comment. Second is what it was bored, could have been better. So with the 93% confidence, it has shown as negative. That's also correct answer. It was boring. I had mentioned boring instead of boring, right? So could have been better. That's why it's shown as negative, but the confidence is little low, because boring, it might not be aware what boring is, but if it is, since it is similar to boring, it, and based on this string, could have been better, it identified it's a negative comment. So it's absolutely a fantastic performance here. Simply outstanding, every actor delivered incredible performance. So that's again a positive one, right? With 99% confidence. Now I tried to provide some, uh, some different type of comments, not specific to movie, but different type of comments to understand how much model learned from the movie data set. Okay, so tasteless product needs some better cooking recipe. Again, seems negative comment, right? Not even, if even not with related to the movie feedback or something like that, but still it's showing as a negative comment, right? So now and it's also being identified by the model recognized it as a negative comment. Yeah, and again, Mars is next to Earth and pretty optimistic, support life in the future. It's positive. Mars is next to Earth but not suitable for life. It means it is negative comment, right? So yeah, you can also think it's a negative comment, right? So model also thought in the same way. So it's a negative comment. Now the last one is Mars is next to Earth and not suitable for life, but pretty optimistic to support life. So it's identified as it identified it as a positive comment, but some lower confidence, because it's a mixture of positive and negative both. But still, model understood that you are trying to emphasize more on the positive thing here, right? So that's how I looks like after fine tuning our model is performing really well, really well, right? So now this is called fine tuning, guys, right? So what we have done, we had seen in the starting, like when we downloaded BERT, a pre-trained transformer, so it was not performing well, not able to identify the sentiments from the input string or for a sentence, right? So or for a feedback, I would say. But then later on, what we did, we trained or we fine-tuned our generic pre-built model, the bert-base-uncased, on the sentiment analysis IMDb data. After the training, it it was fully adapted to classify the sentiments, and when we tested our trained model, so now it was performing well and performing expectedly, and it's able to classify the sentiments whatever we are passing to it. And guys, this is also a model which we had saved it right after training. This also built on the BERT base uncased one only, right? So the same model but fine tuned with additional weights, so it's able to classify the sentiments. So yeah, it's all done, guys. So what in the later steps, what I had done previously, I had tried to uploaded this particular model what I had trained to Hugging Face libraries as well. So just for the use, or uh, anyone can use it for their practice or demonstration or whatever. If they want to learn something, they can download my model and do their task from the pipeline, right? So I had uploaded it on Hugging Face, and I'm not sure if I had shown you before. Yeah, so this is the model I had, the same model, for the sentiment analysis which we had fine-tuned. I had uploaded it to the Hugging Face, so it's ready for use. If you want to use it, you can download it from here using the code. Like, they will provide you the code. Okay, this is the code. You can use it, download it, and do the inference on it. Okay, that's all done, and I think you might have understood what fine tuning is. So if you want to know more theoretically, what's the process of transform, what's the transformer mechanism, how it works, how it performs the natural language processing tasks, so please go through my other video, the theoretical video, like what are transformers, and that should be helpful for you. That's it for now. Yeah, thank you everyone.